This video you are going to see EE8501 Power System Analysis Online Examination Model Questions. Due to the COVID-19 pandemic reason, Anna University will conduct the examination through online. That is clear from official circulars. Also, they released the new question patterns. The duration of the online examination shall be 1 hour. Total marks allotted will be 60, which will be normalized to 100 marks. Part A for 30 marks, that is 31 mark questions. These questions are symbol type, that is remembrance or understanding type questions. Each question contains 4 options for answer. Just click the correct answer. Then part B for 30 marks, 15 2-mark questions. It also a multiple choice questions. These questions are analytical type questions, that is simple problem or simple reasoning type questions. Just thinking and answer the questions. This also for this questions also contains 4 options. Just click the options, but just think and answer, or some small calculations are required. Calculate and answer simple problems. Part A consists of 30 questions, each question carrying 1 mark. First question, OER load flow analysis carried out. The 4 options are to study of stability of system, for fault calculations, for planning the power system, all of this. The correct option is third one, for planning the power system. Then second question, objectives of power system are first option, rated voltage and frequency has to be supplied to the consumers. Neither cost of electrical energy per kilowatt hour is to be minimum, nor rated voltage and frequency has to be supplied to the consumers. Cost of electrical energy per kilowatt hour is to be minimum. Both cost of electrical energy per kilowatt hour is to be minimum and rated voltage and frequency has to be supplied to the consumer. Here the correct answer is fourth option. Both are required, that is cost of energy per kilowatt hour must be minimum. Also the rated voltage and rated frequency to be given to the consumers. Say correct answer. Third question, for n-bus system, size of y-bus matrix. This direct question, n-bus system. For n-bus system, size of y-bus matrix is n cross n. Fourth question, sum of elements of row I equal to shunt admittances connected to bus I. If this summation is 0, indicates there is no, the summation is 0 means there is no element present, that is both shunt elements and no mutual coupling. There is no both shunt element and mutual coupling. Third option correct. Then per unit quantity is defined as, the definition of per unit quantity is actual quantity divided by base quantity. Both are same units. Here second option, actual value of the quantity divided by base value of the quantity in same unit. Then sixth question, the per unit impedance is given by, per unit impedance formula, actual impedance divided by base impedance. Base impedance formula KVB square divided by MBAB. The denominator substitute KVB square divided by MBAB, so that the MBAB goes numerator, cross numerator. So here this is the correct answer. The first one is the correct answer. This is the old value, actual value divided by base value. Base value is KVB square divided by MBAB. MBAB goes numerator. Seventh question, which of the following matrix is used for load flow studies? Load flow studies means is required Y bus matrix. Directly answer Y bus matrix. Next question, which among these following quantities are to be determined in voltage controlled bus? Voltage controlled bus means PV bus or generator bus. A PV bus, P and V values are specified. That's the given value. The calculated values are Q and delta. The load flow equation is solved to calculate the reactive power and the phase angle. The range of acceleration factor is 8th question. The acceleration for the fast convergence in Gauss-Seidel method, you choose the acceleration factor. The acceleration factor values lies between 1.6 to 1.8. It's a correct answer. The 9th question. Load flow study. PV bus is treated as PQ bus. When? The PV bus, that is the generator bus, is treated as load bus. That is the reactive power limit violate beyond the limit. Here the third one is the correct answer. Reactive power goes beyond the limit. The reactive power value is calculated. Reactive power value is less than or greater than, and the limit means you treat that bus as the load bus. Another name of load bus is PQ bus. Then 11th question. The Gauss-Seidel load flow method has following disadvantage. Which of the following statement is wrong? Here the disadvantages are given. One of the disadvantages is the wrong disadvantage. Slow convergence, that is the disadvantage. Then a good initial guess for voltage is essential for convergence. This is also a disadvantage. Then unreliable convergence. This is the answer. This disadvantage is wrong disadvantage. Then choice of slack bus affect the convergence. This is also a disadvantage. Here the wrong disadvantage is unreliable convergence. It reaches the convergence, but it takes time. It's not unreliable. Reaches, but the answer is not accurate. 12th question. Which of the following is the advantages of Newton-Raphson method? Applicable for large power system network. This is the correct. Both number of iterations are less and applicable for large networks. This is also correct. It's applicable, both number of iterations is less compared to Gauss-Seidel method and applicable for large power system network. Time taken for this iteration is less. Is required, the calculation time is large, so required large time. The number of iterations are less. Number of iterations less is the correct. But the second one is correct because both number of iterations are less and applicable for large system network. This covers two advantages. Second point. Then 13th question. Fault calculation using computer are done by. Fault calculation means must required Z bus matrix. The method is Z bus method. Which of the following is correct? Here the subtransient reactance, transient reactance and steady state reactances are given. Subtransient reactance means at the time of fault that happening reactance is subtransient. Then after the fault time the reactance transient. Then after clearing the fault the reactance is steady state reactance. At the time of fault the reactance value is very low. So the here second one is the correct. X double dash D is less than X dash D, which is less than XD. Then 15th question. Three-phase short circuit megavolt ampere to be interrupted by circuit breaker in a power system is given by. That is the short circuit megavolt ampere. Calculated formula √3 into pre-fault line voltage in kilovolt into short circuit current in kilo ampere. The voltage is pre-fault voltage. The current only, the short circuit current is multiplied into root 3. The third option is the correct option. Then 16th question, which of the following result is symmetrical fault? The symmetrical fault means a three-phase fault, three phases are short-circuited together, or short-circuited, and three phases are short-circuited and touches with ground. Here, that one is the correct. All the three phases to earth. So that only the fault current is equal. This is the most severe type of fault. The next question, 17th question. Series reactants are used to. The purpose of series reactants is used to reduce the fault current level. Here, the last option is the correct. Bring down the fault level within this capacity of switchgear. Fault current value is to reduce some level. Fourth option. Then 18th question. Which among these is most commonly occurring fault? The commonly occurring fault, that is approximately 70% of faults are single line to ground fault. First option. The 19th question. If IA1, that is the positive sequence current, is the positive sequence current of the alternator, and Z1, Z2, and Z0 are the sequence impedance of the alternator, the drop produced by the current IA1 will be. The IA1 current, that is the positive sequence current flowing through the positive sequence impedance, the drop is the current into impedance according to Ohm's law formula. So here the drop is the first one, IA1 into Z1. Then question number 21. The positive sequence components of the voltage at the point of the fault is 0 when it is. Here in line to line fault, positive sequence component voltage is there. Also double line to ground fault and line to ground fault. Here all these unsymmetrical faults, the positive sequence component is there. In only one case, the three-phase fault, there is no positive sequence component. So this case only, the positive sequence current value is 0. Then question number 22. A power system is subjected to fault which makes the zero sequence components of current equal to 0. The nature of the fault. The zero sequence current. In case of one of the unsymmetrical fault, the zero sequence component is absent. Only positive and negative sequence components only present in the final diagram. That fault is double line fault. Double line fault. There is no zero sequence component, so there is the zero sequence component voltage and current values are 0. Double line to ground fault. Then question number 23. If all the sequence voltage at this fault point in the power systems are equal, then the fault is. Here in case of all the voltages, that is the positive sequence voltage is equal to negative sequence voltage, that is equal to zero sequence voltage. This is only possible in case of double line to ground fault. Because here in this sequence network consists of the three branches. The three branches are parallel each other. Then question number 24. Which of the network gets affected by method of neutral grounding? Neutral grounding. Depending upon the neutral grounding, the reactance diagram is only varying in case of zero sequence network. So the remaining two networks does not affected by this grounding. So the first one is the correct option, zero sequence network. Then 25 question number, which is steady state stability limit. Steady state stability, it's the ability of the power system to remain in synchronism after subjected to some disturbance. Again, the power system is stable within this stable condition or equilibrium condition, means the power system is stable. That limit here, the correct option is here, the first option, the maximum flow of power through the particular point in a power system without loss of stability when a small disturbance occur. Correct, it's a small disturbance occurring. After that, the maximum power will flowing through this point, means that is in a stability condition. That is the steady state stability, first one. Then question number 26. The stability of power system is not affected by which of these? The stability of the power system is not affected by line losses. Then again the similar question, what is power system stability? The power system stability is the second definition, the ability of the power system to regain the state of operating equilibrium point when the system is subjected to disturbance. Equilibrium condition or the synchronization condition after a small disturbance, that is a stability. After a disturbance, again the power system is stable, that is voltage within the profile limit or frequency within the limit, then power flow is maximum, that means the power system is stable. Then question number 27. The question number 28. The critical clearing time of fault is power system in a power system is related to critical clearing time is related to transient stability limit. Then equal area criteria of stability is used for, this is question number 29. Equal area criteria calculation derivation, here you can derive from the one machine connected to an infinite bus system. Second option is the correct option. Then 30th question. If the torque angle of the alternator increases indefinitely, the system will show the torque angle, that is the load angle, increases indefinitely means the stator magnetic field and the rotor magnetic fields varying. The angle difference between the stator magnetic field and the rotor magnetic field is very large, means the synchronous generator speed is affected. That is called instability. Then part B questions. Part B consists of 15 2-mark questions. That's are analytical type questions. Part B first question. In a 4x4 Y bus matrix, the number of non-zero elements are 12. Find the number of transmission lines. Here just to consider the 4x4 Y bus matrix, it consists of 16 elements. Here 16 elements. Here the non-zero elements are 12. The problem given, the non-zero element is 12. Here, so the zero element is 16 minus 4. The 4 are 0 elements. Here just to mark the 0 elements in this matrix. Here the 0 elements. Here suppose this element is 0. This element is 0 means this element also 0. Because these two are a symmetrical value. Then here this value is 0 means this value also 0. Y23 is equal to Y31. Here I mark the 4 0 elements. Okay, then also I cut the diagonal element. Then what is the remaining elements? Just to count any one of the upper triangle or lower triangle. Here 1, 2, 3, 4. Here the answer is 4. Okay. Only consider any one of the triangle only. Okay. Here just mark in both sides 4 non-zero elements, 4 0 elements. Here mark the 4 0 elements. Then cut the diagonal elements. Then consider any one of the triangle, upper half triangle or lower half triangle. Here in the upper half triangle, the remaining elements are non-zero elements are 1, 2, 3, 4. That is the total number of transmission line. Here the correct answer is 4. For understanding purpose only, I write this one. This can be do in our mind. Very simple problem. The next question. A 30 megavolt ampere generator has inertia constant 0.5 per unit. Find new value for 50 megavolt ampere base. Here this is actual value divided by base value. 20 megawatts. Here in the big question, second problem, 20 into 0.5 divided by 50. that is equal to 20 divided. That is, this one is multiplied this 2, get to 10 divided by 50. 1 by 5, that is 0.2. This is the actual value divided by the base value. Its correct answer is 0.2. Then third question. A per unit impedance of a circuit is 0.3. If the base kilovolt and a base megavolt ampere are halved, then the new value of per unit impedance of the circuit element will be. This problem, the old impedance value and the new base kilovolt and new base megavolt ampere values are given. Both values are half of this actual value. Here, this problem can be solved by using the change of base formula. Z per unit new is equal to Z per unit volt into kVb volt divided by kVb new the whole square into MBAB new divided by MBAB volt. Here Z per unit volt is 0.3. 0.3 into kVb volt. Volt value, just to take the value not given, just to take any one letter V. Voltage is taken as V. The new value is the actual value divided by 2, half of the value, V by 2 substitute. Then here also the new value, megavolt ampere new value is taken as P by 2. That is, actual value is taken as P. The new value is half of the value. So here taken as P by 2. Then simplify 0.3, here V cancel, the whole square, that is equal to 2 square. 2 square is 4. Then PP cancel, divided by 2. That is 0.3 divided into 2. That is, answer is 0.6. Then question number 4. A network consists of 100 buses in which 10 are the voltage control buses, 5 are fixed shunt capacitor buses, 20 are the reactive power supplied buses, 6 are the generator buses. Find the size of the Jacobian matrix. Here this question, fourth question. The Jacobian matrix size can be calculated by using this equation. 2n minus m minus 2. N is the number of buses, total number of buses. M is the total number of generator buses except a slack bus. 2 minus 2. Well, here write 2 into a number of buses. Here total number of buses are 100 minus here the generator buses, in which 10 are the voltage controlled bus. Voltage controlled bus is the generator bus. Here one of the bus is the slack bus. So here I subtract the slack bus. So it take 10 minus 1 is taken as 9. Omit the slack bus. The remaining buses are 9 buses. Then second, 5 are fixed shunt capacitor buses. Fixed shunt capacitor buses are not a generator bus. It's taken as the load bus. So omit this bus. Then 20 are the reactive power supplied buses. Reactive power supported bus or supplied bus. This is also a generator bus. Here plus 20 plus, then finally 6 are generator buses. Here also take 6 minus 2. Then simplify this. That is 200 minus 35 minus 2. Then simplify, that is equal to 163. Here the answer is, the matrix size is, the Jacobian matrix size is 163 cross 163. Second one is the correct answer. Then fifth question. The zero sequence current of the generator for line to ground fault is J2.4 per unit. Then the current through the neutral during the fault is, the zero sequence current of the generator line to ground fault. That is a single line to ground fault. All sequence currents are same. This in case of single line to ground fault. Here the fifth question, single line to ground fault. IA1 is equal to IA2, that is equal to IA0. Then fault current is equal to 3 into IA1. Over here, the zero sequence current for single line to ground fault is given. That is J0.24. J2.4. J2.4. That value is 2.4. J is 2.4. Over here, that value is equal to IA1. Just to multiply 3 into 2.4. J2.4, that is equal to J7.2. J7.2. Option C, that is the correct answer. Then sixth question. The following sequence currents were recorded in power system under a fault condition. Positive sequence current J1.923 per unit, negative sequence current minus J0.8 per unit, zero sequence current minus J1.246 per unit. What is the fault? Here the three fault currents are different. The fault currents are different in case of double line to ground fault. That is here the third option, line to ground, double line to ground fault. Double line to ground fault, the currents, the sequence currents are different. The sequence voltages are same. So here the three currents are different. So here third one is the correct answer. Then seventh question, 2 mark seventh question. A inertia constant of two machines which are not switching through the inertia constant of two machines which are not switching together are M1 minus M2. The equal area constant of the system is. Here just to take the difference. So first one is the option, first one is correct, M1 minus M2. Then eighth question, question number 8. The bus admittance matrix of the network shown in figure, for which of the marked parameters are per unit impedance? That is, just to calculate the admittance matrix for this line diagram. This is question number 8. Question number 8. Here, the line diagram. This element is Y11 means the element connected to node 1. Some of the elements connected to node 1. Here, the given elements are impedances because here these are the positive values. Impedance are also mentioned in the problem. Per unit impedance values are given. Or here, take the reciprocal of the impedance. Here, this element connected to node 1 is 1 divided by 0.1 plus 1 divided by 0.2. But here Y11 is 1 divided by 0.1 plus 1 divided by 0.2. 1 divided by 0.110, 1 divided by 0.25, that is 15. Here the option D only, Y11 value is 15. So I directly answer this question, option D. Also check for this Y22 value. Y22, that is here only one element connected to this node 2. 1 divided by, that is equal to 1 divided by 0.2. That value is equal to 5. Y22 value is 5. This is the correct answer. Y22 is 5. Then Y12 is equal to Y21. That is the minus of 1 divided by 0.2. That is minus 5. Option D is the correct answer. Then ninth question. A power system network consists of three elements: 0 to 1, 1 to 2, and 2 to 0. For per unit impedances, 0.2, 0.4, and 0.4 respectively. Its bus impedance matrix is given by. Here, the bus impedance asked bus impedance matrix. For understanding purpose, I draw the line diagram. This is 0th bus, bus number 1. This is bus number 2. Here 0 to 1, the value is 0.2, 1 to 2, 0.4, 2 to 0, 0.4. I am going to form this bus impedance matrix by using a bus building. algorithm. First add this branch, add a branch of impedance 0.2 from the reference bus to new bus. Just add this element. First I add this branch. Then second I add this second branch. That is the branch of impedance 0.4 from the existing bus to new bus. This is come under case 2. In case of case number 2, copy the row value and column value. Then the diagonal value is equal to this previous diagonal value plus this branch impedance. Here the previous diagonal value is 0.2 plus 0.4, that is 0.6. Then this is completed. Then add the last branch. Here add the branch of impedance 0.4 from existing bus to reference bus. This is come under case 3. The case 3 is similar to that of case 2. Just to copy the column values, also the row values, form the new column and new row. Then diagonal value is equal to sum of this previous diagonal value plus this branch impedance 0.6 plus 0.1, that is 1. Also it's required the elimination. Eliminate the last column and last row by using row elimination formula. Row elimination formula is JK new. ZJK new is equal to ZJK old minus ZJ into n plus 1 Zn plus 1 into K divided by Zn plus 1 into n plus 1. I am going to form this value, new value. I find this new value. This is the old value 0.2 minus Zjn plus 1, that is this one. The last value 0.2 into n plus 1 into k, that is this one value, this 0. Divided by n plus 1 into n plus 1, that is 1. Here 0.2 minus, the answer is 0.2 minus 0.2 into 0.2, 0.04. That value is 0.16. Here the three options contains 0.16, 0.16, 0.16. Also I am going to calculate the another value, reduce the value, calculate this value. Here that is equal to, that is Z12 new. Z12 new is equal to 0.2 minus 0.2, this value into here this one 0.6 divided by 1, that is equal to 0.2 minus 0.12. That value is equal to 0.08. This one. This is positive value plus 0.08. Over here the option D is the correct answer. Also I check one more value, calculate this value 0.6, this value is set, this place is Z22 new is equal to old value 0.6 into minus 0.6 into 0.6 divided by 1, that is equal to 0.6 minus 0.36. Subtract this 0.60 minus 0.36, that is equal to 0.24. Here confirmed that D is the correct answer. Then question number 10. The positive, negative and zero sequence impedance of the solidly grounded system under steady state conditions always follow the relation. Here in steady state condition, the positive sequence impedance is greater than negative sequence impedance, which is greater than the zero sequence impedance. Here first one is the correct option. Eleventh question. A simple power system network is shown in figure. The reactance marked in per unit, the per unit values of Y22 of bus admittance matrix is. Calculate bus admittance matrix for only one element Y22. That is the elements connected at bus number 2. The given values are positive value, so the given values are impedance. I will write 1 divided by that value. Here the element connected to this bus number 2 is 1 divided by J0.2. Here I write Y22. Here I write Y22 is equal to 1 divided by J0.2 plus 1 divided by this one J0.2 plus 1 divided by J0.1. 1 divided by J0.2 is minus J5 plus minus again minus J5 minus J10. 1 divided by 0.1, 10. That is equal to minus J20. The answer is minus J20. Then question number 12. A 3-bus network is shown in figure below, indicates the per unit impedance of each elements. The network shown, the bus admittance matrix Y bus for the network is. Just to calculate the Y bus. Similarly, calculate the Y bus by using the bus inspection method. Here at Y11 is equal to sum of the element connected to node 1. Here the given values are impedance. So take the reciprocal 1 divided by J0.1. Again, so for this problem number 12, 1 divided by J0.1, Y11 value 1 divided by J0.1 plus 1 divided by J0.2. These two elements are connected as bus number 1. That is equal to 1 divided by J0.1 is minus J10 minus J0. Minus J5 that is equal to minus J15. Here this answer B answer minus J15. This answer only contains Y11 value is minus J15. B is the correct answer. Also check another answer. Y12 is minus of 1 divided by Y12 is minus 1 divided by J0.2. That is equal to plus J5 plus J5. Okay, so this is the correct answer. B is the correct answer. Then 13th question. A zero sequence circuit for 3-phase transformers shown in figure given below. Here the primary side star connected. There is no grounding. Then secondary side delta connected. In this case, the delta connected side is open. That is the secondary side is open. So here also the B is the correct option. Then 14th problem. For a power system shown below, specifications of components are followed. G1 25 kilovolt, 100 megavolt ampere, X is equal to 9%. G2 25 kilovolt, 100 megavolt ampere, X is equal to 9%. T1 25 kilovolt per 220 kilovolt, 90 megavolt, X is equal to 12%. Here all the data are given. The line diagram also given. Choose the base of 25 kilovolt, that is the generator side at the generator G1, and 200 megavolt as the base value. 200 megavolt base value choose panno. Then the impedance diagram is calculate the impedance diagram. The per unit impedance diagram. Here using the formula X per unit nu is equal to, or Z per unit nu is equal to Z per unit volt kVb volt divided by kVb nu the whole square divided by MVAB nu divided by MVAB volt. Using this formula easily calculate. Just to calculate any two values, so find out the answer. Here I'm going to calculate the first element, generator 1. The generator 1, the per unit old value is 0.09. Z per unit for generator, new per unit. This is the new value for generator into here the old value is 25. The new value also 25 the whole square into MBAB new value. The base value is given. New value is 200 divided by here this old value is 100. But that value is here this 2 are cancelled, then multiplied into 2. The 0 cancel is multiplied into 2. That value is equal to multiplied into 2, you get J 0.18. 9 2s are 18. 818. Then I am going to calculate the for another one component for check the answer. I'm going to calculate the transmission line. The transmission line, the old value is 150 ohm. That is the actual value. Then calculate the base value. Base value is transmission line base value. Base value is KVB square divided by MBAB. Here in case of transmission line, the voltage is 220 square. The base value not change because here the 25 volt, that voltage is converted into secondary side. That base voltage also 220 kilovolt. The old value and the new value both are 220. Here I take the new value. New value of this base value is 220 volt, 220 kilovolt. The whole square divided by MBAB new. MBAB new is 200. Then simplify this one. Simplify this one by using the calculator. Here in your examination, your calculator option is available. It's not taken from your system calculator. In your examination software also provide the calculator. You use that calculator. I am using this here. I am using the system calculator. 220 into 220 divided by 220 into 220 divided by 200. That is equal to 242. Then the actual value, per unit value of the transmission line, per unit value is equal to actual value divided by base value. Here actual value is 150. 150 divided by 242. 150 divided by 242. That is equal to 0.6198. Just to look at this answer here, this value is J.62. Here this one, only one option that contains J.62. Here option B is the correct answer. The last question. If the generator of 250 megavolt ampere rating has the inertia constant 6 megajoule per megavolt ampere, its inertia constant on 100 megavolt ampere basis. Here just to multiply these two values, that is the actual value megavolt ampere into this is inertia constant to get the actual value divided by the base value. 250 into 6 divided by 100. You get the answer is 15 megajoule per megavolt ampere. All the questions answered are correct. This is the way the online exam is there. The part A questions are very simple. Directly you answer the questions. The part B questions and just applying, use the formula and applying by using calculator or in mind calculations, calculate the answer. In actual online examinations, don't use the paper pen for our for calculations. And very simple calculations for our understanding purpose only. I am using the paper for calculating. the answers. Examination, you bring the formula in your mind and substitute the values in the calculator. That option is given in the software and find the answer directly. The examination link is provided in this description box. You can also attend the examination, practice this examination by using this link. Thank you.